Were you here for this? No, I don't think so. Oh, you were here for notes on 183, right? So I'm going to have you do this guided practice by yourself in a second, but I'd like to do the warm up together to review one of each method before you do the guided practice on your own. So let's go through the 5 different kind of methods. Conjugate is if you see a radical, you're going to try this trick. You're going to multiply the top and the bottom by the conjugate of the radical. So you wouldn't necessarily know to do this by yourself, but it's one of our methods. If you see a radical, so my conjugate is going to be the square root of x plus 5 on top and bottom, because that's like multiplying by 1. Like it's kind of hard to see. All right, so in the numerator, you're going to do your FOIL. So the nice thing that happens is when you take the square root of x times the square root of x, now you just have x in the numerator. Outer and inner are opposites. You get 5 root x and negative 5 root x. That adds up to 0. And then you have negative 5 times 5 is negative 25. So I have x minus 25 in the numerator. You don't want to distribute the denominator at all. So the denominator is just the 2 factors that I started with. 25x minus x squared and the square root of x plus 5. So it would have been nice if I had x minus 25 on top and bottom that could cancel with each other. I actually do have x minus 25 in here. It's just disguised. You can factor this using a greatest common factor. To get x minus 25, you're going to have to factor negative x out of both of these terms. So if I factor out a negative x, I'm going to rewrite this in a different order, but if I take out a negative x, won't I have a positive x left? And if I take out a negative x, won't I have a negative 25 left? Right? If I divide this by negative x, I'll have negative 25. I just switched the order so that you could see that, yes, it is the same exact term, right? Negative x times x is negative x squared. Negative x times negative 25 is 25x. But now I can see that those x minus 25s do cancel with each other. So my final function is now 1 in the numerator over negative x times the square root of x plus 5. That's a lot of algebra. So now I'm finding the limit. My last step is now I'm going to plug in the number 25 into the denominator x's and see what I get on my calculator, or see what I get. So that would give me negative 25, and this is going to give me positive 10, isn't it? Because this is 5 plus 5. So negative 25 times 10 would be negative 1 over 250, right? So that would be my limit. As x approaches it, it's undefined, but when I cancel things, I can evaluate the whole, and the whole happens at negative 1 over 250. So to me, the conjugate one is the hardest one that you'll do, because the others are just factoring, canceling, substitution, or that trig form we talked about. So on number 2, I didn't leave you much room, so if you want to go up to do the work, that's fine. You are going to try to plug in 0. Oh, you can't, because you get 0 in the denominator. So we need to do some factoring and canceling. So our first step is to multiply out 6 plus h times 6 plus h in the numerator, and to simplify the numerator. So 6 times 6 is 36. And then 6h and 6h would give me 12h plus h squared, oops, minus 36. I forgot to include because there's a minus 36 up there. And then all over h. So FOIL 36 plus 12h plus h squared. There's that minus 36 that's hanging out over h. What would be your next step? Does anyone remember the next step to simplifying this from last class or 2 classes ago? I still can't plug in 0. I got to get rid of that h. You remember what to do next, Eve? Yep, that adds up to 0. Good. And then what's your next step? How do I get rid of the h? Simplify or factor the numerator, right? If I factor out an h, I have 12 plus h left. And then I have h in the denominator, right? GCF, I can pull out an h from both of those terms. So I have 12 plus h left after I cancel the h's, which is great because then I can go and plug in the 0 that I want to plug into the function because it's not undefined anymore. So what is the value of that limit? 12 plus 0 is 12. So the limit is 12 for that function. Number 3, this is on the trig form set of notes. This is the only trig form that I'd like you to have memorized. Whenever you see a sine of 8x over 4x or sine of ax over bx, if x is approaching 0 in the denominator, this function will approach 8/4. It's kind of like the rational function rule, although the rational function rule is when the powers are the same. But so 8/4, this is going to approach 2. And we looked at a graph of this just to kind of hit it home, but the sine of 8x over 4x, if I put it in radian mode and zoom 6, see how my function, here's that function in the calculator, it kind of oscillates. Let me focus it. So it oscillates right around 0, and then right at 0, it does shoot up to 2 on the y-axis because 8/4 is 2, but there's a hole right there. So in the table, if you looked in the table at 0, it approaches 1.99 on the left and 1.99 on the right because it's approaching 2 at 0, even though there's an error there. So it's kind of the same thing as like a hole in a rational function. And then the last two strategies. Number 4 is just a factoring and canceling, and number 5 is direct substitution. Can you try 4 and 5 for just a minute on your own before I do 4 and 5, and then we're going to go on to the guided practice. Being able to factor, cancel, plug in -5, you'd get -10, and then absolute value, but you're just plugging in 1 using direct substitution, so you'd get 9. So those are the 5, like substitution, factoring and canceling, trig form, conjugate. Those are the things that you're practicing on this previous page. And I don't think we've done this previous page, right? So I'd like you to take the last